In today's lesson, we're going to take a look at standard ES4 magnetism. And a magnet is any material that produces a magnetic field around it. And you can see that I've pictured a bar magnet here on the right. And you can see it has two symbols, one on the top north, one on the bottom south. Every magnet has two poles, a north pole and a south pole. When we talk about magnetism, it's important to realize that any sort of magnet, the poles have a relationship together. So the two south poles will feel forces of repulsion between each other, and the two north poles will feel forces of repulsion against each other, but a north and a south pole will attract. So like poles repel, and opposite poles will attract. When we talk about magnetism, at the base of all magnetism is moving charges. Moving charges are what create magnetic fields. The field lines that we show around the magnets, they show how a north pole would move, how north poles would move in the electric field. And we can see right here on the diagram below that we have field lines in blue that are showing a field that goes from the north end of the magnet to the south end of the magnet. And this is how north poles would move. A couple things about drawing north poles. First of all, we never cross any lines in drawing north poles. It's very similar to electric field lines. The density of the field lines are going to tell you where the magnetic field is strongest. And the field lines always start on the north pole and always end on the south pole. One of the ways that we understand magnets is through compasses. Compasses are tiny little magnets that will align themselves due to the magnetic presence of the field. So they'll orient themselves from north to south. And so that means the magnetic needle on a compass will always point to the magnetic south pole. On the planet, while we have geographically the north pole, that is magnetically the south pole of the planet. So the compass needles always point geographic north, but magnetic south.